The first category of rocks are called the igneous, I-G-N-E-O-U-S, igneous. Igneous rocks are by far the most abundant rocks that occur as a part of the mineral matter in the soil. It is estimated that originally up to 95% of the Earth's crust consisted of igneous type of rock formation. Two of the most important ones are the basalts and the granites. The basalt being darker in color and finer in texture, and the granite type materials being much coarser in texture and, of course, lighter in color, more crystalline in nature. A second category, general broad category of rocks, are the sedimentary. Now, sedimentary, by definition, is inferring rocks of secondary origin. So sedimentary rocks are actually formed predominantly near the Earth's surface as a result of the breakdown of the minerals that are occurring as a part of the primary parent material, in this case the igneous types of rocks. Examples of sedimentary rocks include shale, sandstone, and limestone. Now, one of the things that all of these types of sedimentary rocks have in common is that they're relatively non-resistant to breakdown or weathering. And I think that would make sense because igneous are composed predominantly of primary minerals, whereas the sedimentary are much, much higher in secondary minerals, which are going to naturally be less resistant to weathering and breakdown. Finally, the third general category of rocks are called metamorphic. Well, metamorphic is a biological term, and here we're dealing with mineral matter, which is not really from a living entity. Yet we can still use this term metamorphosis. That's where the term metamorphic comes from. Metamorphosis in terms of plants and or animals is implying a change in form or structure as they go through development. Well, that term also applies to metamorphic rocks. Rocks which are called metamorphic or fit into this category have gone through an extensive amount of change as a result of time and development. It requires heat and it requires pressure for metamorphic types of rocks to form. Therefore, these are not forming initially at the surface of the Earth's crust, but rather they are forming at deeper depths below the surface of the Earth's crust, where we will see pressure and or heat developing. These examples of metamorphic rocks include marble, as an example, slate, which used to be used quite a bit on blackboards, but now we use primarily dry marker types of boards. These types of rocks are the least abundant of the three that we've discussed, those being igneous, sedimentary, and metamorphic, and are really not of a great deal of importance when it comes to what I call the active soil forming environment, that area near the surface of the Earth's crust where soils are most actively forming or developing. Now, through different types of geological shifts and changes, we can see these occasionally being brought up near the surface of the Earth, but even when that happens, it happens or occurs in fairly small geographical areas. So we're going to be looking at the igneous type of rock because, of course, it has most of the primary minerals. It's the most abundant, and it is the one that kind of dictates what types of soils will be formed in a given area based upon the climate and weathering of that particular area. If you don't have an appreciable amount of certain types of elements in the rocks, then you can expect that no matter what type of development of that soil takes place, that soil will naturally be inherently low in that particular type of element. And then, of course, we're going to be looking at sedimentary because those are the ones that are most predominant at or near the Earth's surface in the active soil forming environment. Whether that be only the top few inches because we're in a very arid or dry type of climate, or whether it be the top 1 or 2 feet or more of the soil profile because of if we happen to be in a subtropical type of area where we had higher temperatures and much more greater deal of moisture available to aid in the development and maturation of the soils.